who has Eclipse installed, if you could open up Eclipse right now. I'm going to begin with going over like a homework solution. And it looks like most people didn't have too many problems with the actual coding. Most of the issues were just like maybe Eclipse wasn't working or things like that, which I'm happy to see. So let me begin my screen share. And I'm going to make a new class for the homework solution. So just as a reminder, you want to find your package, you want to make a new class, and I'm going to call this one class 2 homework solution. And include that, finish. So we have a brand new file. And I think what most people had was something like this. Oh, I see, Lucas. Yes, we did have homework. No worries if you forgot about it. If you can, though, I guess look it over on Google Classroom and just, if you have time this week, do it along with the homework I'm going to assign at the end of class today. We generally have a small homework assignment every week just to practice what we've been learning in class, so we don't forget for the next week. But yeah, no worries if you forget the homework of 1 week. It's not too bad, but try to get it done at some point if you can. All right, so what most people did is something like, let's use some doubles. So the Fahrenheit temperature might be, let's do like 97. And then the first thing we do is maybe some temporary variable. We subtract 32 from it. Oops, and I don't want to use 97 here, I want to use the variable. And then the last step is generally the times 5 divided by 9, multiplied by 5/9. So then I can say like double y equals the temporary variable times 5 divided by 9. And then I'm just gonna call this C for Celsius, and then we can print it out. So something like this. And if I run it, looks like it's about 36. I'm not gonna check this with a real calculator, but that seems about right. I can try, I know 212 should be 100. And if we do that, yeah, it's 100. So this is what most people did, which is perfect. Some of you guys I saw use different data types. So here I used a double, and other people used ints. I saw was also common. And nothing wrong with that. So if we try to replace everything with an int, perfectly fine here. Still gives me 100. But if we go to like the 97 from before, you'll see we'll get a slightly different answer. We get 36. And that's because ints, unlike doubles, are only for integer values. They only are for whole numbers. And so it doesn't do like 36.1111. It does just 36. What you chose was up to you. And sometimes you'll want doubles, sometimes you want ints. One thing I want to ask you guys is if for some reason we decide to use a mix of values. So perhaps I wanted to use doubles here. So that's perfectly fine. But if you notice, if I change this one back to an int, I have a problem. And without me hovering over it, does anyone want to tell me or tell the class why the code here has a problem? Why will this not run?
It's an equation, so it has to be in parentheses.
So parentheses are not the issue here, but I do want to talk about parentheses later. Oops. So like I can put parentheses here, or I can put parentheses around the whole thing. It's still going to be complaining, but good guess, Tushar. It's something to do with data types. Does anyone else want to give a try?
The out C has to be an integer, but X is a double.
Yeah, great. So it is a type issue. So on the left-hand side, we're declaring a variable called c, and we say the type of it has to be an int. So what's on the other side of the equal sign better be an int. Unfortunately, if we look at this, 5's an int, 9's an int, but x is a double. And so something that's happening here is that Java implicitly converts everything kind of up in terms of the data types. So we talked about like smaller data types and bigger data types. Doubles are kind of a larger data type than an int. When I say larger and smaller, one way to think about it is, can you represent all ints as a double? Can you represent all doubles as an int perfectly without losing information? And so one of those ways is fine. You can represent all integers as a double without losing any information, right? Because the integer 5 is just the double 5.0. But you can't go the other way around. You can't take a double like 5.3 and convert it into an int without losing information. You have to either round or truncate. You're going to lose the decimal somehow. So you can convert ints to doubles without a problem, but you have to be careful about trying to convert doubles to ints. And so what's going on here is this is a double. And so it's saying, okay, x times 5 is going to be a double, divide by 9, that's still a double. And so what's on the right-hand side is a double type, but on the left is an int type, and you can't convert implicitly, at least. I'll show you how to convert in other ways later in today's class. But you can see if I hover over it, it tells us the error, type mismatch cannot convert from double to int. And so really, probably what you want to do is if you use int at the beginning, you want to use int all the way. If you have double, you might want to do doubles all the way. Lucas, you have your hand raised. Do you have
Is there any way to convert a double to an int if I have to do it?
Yes, so great question. There is a way, and I'll probably be talking about it very shortly. But yes. Yeah. All right. Just a couple more things I want to talk about this homework assignment. One thing I also saw people do is, if we just change this all to doubles for a second. Some people notice that we can do everything in like 1 line or 2 lines. Times 5 divided by 9, for example. And in Java, we have order of operations. Hopefully you learned that in math class, but if not, when you're doing like math, there's an order to which you apply the operators. So first you do multiplication and division. They have the same priority. And then you do addition and subtraction. So you need the parentheses here, or else Java will also do order of operations. If you don't have the parentheses, then it will do the multiplication first, then do the division, and finally do the subtraction. But we don't want that. We want to do the subtraction first. So if you want to do it in 1 line here, you have to have the parentheses. All right. So for example, just to show that the results are different, if with the parentheses, we get the right answer, which is the like 36.1 repeating. If you don't have the parentheses, then it's going to give some wrong answer. It's going to give us 80. And the last thing I want to talk about is something new. So this is going to be new information, and it's dealing with this division operator. So I'm sure everyone is familiar with how division works, right? Like 5 divided by 9 is just a fraction. It's a little bit more than 1/2. But division in Java can be a little bit tricky, especially if you're not familiar with data types. So let me come up with something that looks like it should maybe be correct, but actually has a big problem. So let me change everything to ints, just for now, and show off the proper answer should still be 36, right? So 36, right? So I'm going to change my code to be like this. So int, I don't know, factor is this 5/9 thing, right? And now I'm just gonna take my F Fahrenheit temperature minus 32 and multiply it by our factor, 5/9, right? Now, if I print out this, it's not gonna work, but does anyone have a guess, just a guess of what the output is gonna be here? Right. You can make some guesses without sharing it with the class, but I'm gonna run it now. And we'll see the answer, confusingly, is 0, right? So it looks like I didn't do anything special, right? Just to show you I'm not doing anything too tricky. If I replace this factor with 5 divided by 9 again, and run it here, it gives us the right answer, 36. But if I replace this with our variable, it becomes 0, right? So something's going on here that maybe isn't what we really want. So knowing this, knowing that the answer here is 0, that it's printing out 0, and it's probably having to do something with this factor. Why, does anyone have a guess of what's going on? Owen, I see your question in chat. So if you're getting stuff with like module up here or public class with module, I'm not too sure about what's going on, Owen, but maybe after I go over this homework program, I will.
Oh, wait, I think, sorry, I should raise my hand.
All right, so Evan guessed first that an int can't store a variable equation. So it's not quite because it's a variable equation, but it is something to do with ints. Lucas, do you?
It's because 5 divided by 9 rounds down to 0 because it's an integer.
Yes, so
Which is
that's basically
yeah.
the answer. So what's specifically going on here is that division in Java defaults to integer division. And what integer division means is that you perform the division and then you convert it to an int. Another way you can think about it is it's like division when you first learned it, right? So it's like, how many times can 9 go into 5? Well, 5 is less than 9, so 0 times. 9 can't go into 5 a single time. If we try something different, like, I don't know, 30 divided by 9. 30 divided by 9, you can think of it as how many times does 9 go into 30? Well, it can go in once, twice, 3 times, but it can't go another time. So it stops at 3. And so here, factor would be equal to 3. However, when we have it 5 divided by 9, this becomes 0. So here, if I print out, one sec. Okay, my Zoom disappeared for a second. But if I print out what factor is, you'll notice that it's 0. Right? I'll even get out of this one to make sure we're printing out here, but it's 0. So this is the problem right here. We're doing integer division. And so the reason why it wasn't an issue before is actually it's still doing integer division, but because of order of operations, it's doing this multiplication first. So this becomes some large value and the division kind of works, right? We're still truncating to an integer in the end, but because we do the multiplication first, it kind of gets rid of the problem. You might think though, well, okay, so this is integer division. What if I want a decimal, right? What if I replace all of these things with doubles, which we know is for decimal values? Unfortunately, if I run this, it's not going to work still, right? So what happens is factor is still 0. The only difference is now it's 0.0, which is so helpful, of course. you can see that, well, okay, I did 5 divided by 9 here, but if I use the variable, everything's still 0, which is a problem. So the solution to this is actually force this division to do floating point division, decimal division. And the way to do that is one of these has to be a double. So I can do 5.0 divided by 9, or 5 divided by 9.0. And so what happens here is that Java sees, hey, you want me to do division, but you're using an integer and a double. And so to be safe, I need to turn this value into a double value. I can't do integer division because you have doubles here. So I have to work with doubles everywhere. And so now if I do this, you can see it kind of actually works. So factor is correctly 0.5 repeating, and the value that we get is 36.1111. Okay. So this is something new. Talking about operators, division operators, and the fact that you have to be careful with it, right? So here we're doing division. Both things are integers, and so Java says, hey, I'm going to do integer division. And then it gives you 0 and you get confused, maybe. Right? So yeah, that's one thing I wanted everyone to watch out for. Just a connection with Python, because again, I know a lot of people came from Python. Integer division actually exists in Python as well. The only difference is that in Python, integer division is not the default, but you can ask for integer division by doing 2 divide signs. In Java, that's a comment, but in Python, you can do 2 division signs, and that tells Python, hey, do integer division. So this is something that's not unique to Java. The only thing that's unique to Java is that it's the default. Okay. And just to show, as long as I make one of these a double, it will work. All right. All right, so that's pretty much all I had for homework. I want to see if anyone has any questions about the homework. How to come up with a solution, anything we talked about just now. All right. If not, I know, Owen, I want to go back to you. Seems like you had an issue with Eclipse that it was replacing some of your code. Do you want to share screen? Stack Overflow. Okay, there's a lot of errors. I see. So something that's going on here is that when you created your project, you have something called the module info.java. So if you look on the left on your package explorer, and this is for everyone, when you make your projects, by default, it'll put something called that module info.java file. Your mouse is right click. If you move your mouse slightly up, yeah, that file, you really don't want it. And so you can delete it if you want, but you might also want to just recreate your project. And when you create a new project, there'll be a checkbox that says include it or not. And I don't know if you're sharing your whole screen. If not, then that pop-up might not show up for everyone to see. But maybe, Owen, if you give me back the screen share. So I'm gonna see. So when you make a new Java project, there's this checkbox. It's a little bit hard because, so test project, it's not right here. You have to click next. And on the second page, there's this checkbox that says create module info.java. For this class, we're gonna not check it. We're gonna deselect it. If you do select it, then it automatically creates that file. It causes some problems. And so we're just not gonna deal with it. and we want to deselect that. The other thing is that if you're using the project, you can delete that file. But the other thing you want to be careful about is you want to put your code inside something called the default package. So when you make a new class, all right, so let me actually go to my project. When you make a new class, we'll do something called the source folder, and it'll also ask for the package in the second box. If we don't select that module info.java, by default, it'll be blank, and that's called the default package. But if you did select that module info.java, it will, I think, create a package by default, or it'll create a package and it'll have that name here. And that also causes problems. You want to make sure that this is empty for pretty much everything we're doing in this class. Right. So Owen, try those things, make a new project, deselect, create module info.java, and let me know if you're still having problems with that. Does anyone else have any questions about the homework or really anything in this class setup? Things aren't working, having trouble using Eclipse. Any questions? I don't see anything in chat. Don't see any reactions. All right. Let's go here. So with this material for today's class, well, we have this chart from last class. It's kind of intimidating, but really don't be too scared. Just remember we have kind of all of these are the same family of variable types. We're mostly going to be using ints, but these are all just storing whole numbers. And the only difference is the size of these variables. And because of that size difference, it determines how big of a range of values that these things can hold. So ints, which is kind of our default, hold anywhere between -2 trillion to +2 trillion, which is probably going to be big enough for most things you're going to do. Sometimes you want more, sometimes you want less. And then we have our floats and doubles, which are decimal values. And in this case, double is going to be our primary data type that we're going to be using as the default one. And then we have Booleans and characters. And so that's where I want to begin class right now. And I know someone asked converting doubles to ints. We will be getting to that later, I promise. I haven't forgotten about that. But first, Booleans and characters. Where is it? Booleans. So Booleans are a very simple data type. You might have seen it from other programming languages, but Booleans have only two values, true and false. So in Java, these are represented just by the literal word true and false. There is no capitalization. Everything is lowercase. And yeah, so we can declare Boolean values just like, I think we did it before maybe. All right, okay. So I can say like Boolean b equals true. And then I can print it out. And we can have true. I can say it's false. Prints out false. Not a big surprise. Notice that the true and false become kind of bolded and kind of purple. And that's just to represent true and false are special values in Java. And again, because they're special, you can't make a variable called true, right? It can have the value true, but you can't name the variable true or false. And there's also something that we can do to make Booleans. So here is an operator that you're probably familiar with, greater than operator. And here what we're doing is we're creating two numbers. X is equal to 6, y is equal to 11. They're both integers. And we're printing out x greater than y. And so this might be a little bit confusing, but remember in programming, when we use the greater than, less than operators, we're not doing the same thing as in like math class. So we're not saying that this is a correct statement. We're not saying x is larger than y. We're kind of asking a question. We're saying, is x greater than y? And so the answer to that is either true or false. In this case, because x is 6 and y is 11, the answer is no, it's not true. So here it's going to print out false. If we swap it around, is x less than y? Then the answer to that would be true. So to show that off, I can say like here, x equals 5, int y equals 10. So I'm just going to print out x less than y. And in this case, 5 is indeed less than y, 10. So the answer is true. If we flip it, then it is false. And it should be obvious, but I want to point out 5 and 5. Is this going to be true or false? Anyone in chat, speak up. What will this print out?
False.
Yeah, false. And kind of said why? They're equal. So x is not greater than y. It's equal to y. So this is not true. Right? It is not greater than y. So here, false. I'm taking a moment to go over the other operators. So I'm gonna put this in chat, but I'm also just gonna show it off. Nothing too important here. We've already covered a lot of this just in this class. So these first four should be very familiar to you. They're the same as in math class, nothing too special. Plus, minus, star for multiply, slash for divide. The next one you might be familiar with, you might not be, but this is called the modulus operator, also called mod for short. And it just gives the remainder of a division. So like 5 divided by 2 gives us 2, because 2 goes into 5 2 times. 5 mod 2 gives us the remainder. So if we take 5 divided by 2, well, it goes in twice, and then there's 1 left over. So 5 mod 2 is going to be 1. I can show it off. Right, so if x is 5 and y is 2, I can print out x mod y. And again, this just takes the remainder and prints it out 1. So just to check, if I do like, I don't know, 8 mod 3, maybe Sophie, you're on the top of my Zoom list. You don't have to have this on your own computer, but can you tell me what this is supposed to be? What will be printed out if I do 8 mod 3?
2.
Yep. So the remainder, if you divide 8 by 3, will be 2. Mod will be actually very useful. We might not see a lot of it in this class, but the most common use of mod is going to be with modding 2. And because a lot of times we want to know if things are even or odd. So if you take a number and mod it by 2, well, it's either 0 or it's 1. If it's 0, that means 2 went in perfectly, evenly. There's no leftovers. And that means it's an even number. If the number mod 2 is 1, then we know that there was a leftover. We know it's an odd number. It's not divisible by 2. Then we have the plus plus and minus minus operators. These probably are new, but shouldn't be too hard to understand. They are our increment and decrement operators. So the plus plus increases it by 1, minus minus decreases it by 1. So for example, if we So these can be used a little bit differently. So they can be used standalone. So I can say x is 8, and then I just say x minus minus, and then x minus minus again. And then if I print out what x is, well, it becomes 6, right? Because we started with 8, and then we decrement it. So it starts at 8, becomes 7, becomes 6. There's also something a little bit different. You can also put the decrement or increment before. So this looks a little bit funny, but it does the exact same thing. So we start at 8. This is still a decrement. So it still becomes 6. The only difference is when we have something like this. So if int y equals minus minus 6. So this is also a valid expression. So here, if we print out y, we'll see that y is 7. So notice it started with 8, it decremented, and then assigned the value. If we do it, also, let me also print out x. So y is 7 and x is also 7. If on the other hand, we had the minus minus at the after the x, we get something a little bit different. Y is 8, but x is still decremented. X in both cases becomes 7. That shouldn't be surprising. We're using the decrement on x. It should become 1 less. The only difference is what y is. And that's because with the decrement after the variable, what it does is it first does the assigning. So y becomes 8. And then it decrements x. So then x becomes 7. If we have the decrement first, then it decrements. So x becomes 7. And then we do the assignment. So y also becomes 7. Lucas, I know you had your hand raised. You have a question?
If I wanted to decrement by more than 1, would I have to write a for loop, or can I just like put a number in front of the negative signs?
Good question. There's actually another operator that comes in handy, and we'll talk about that right now. So those are called our arithmetic operators because they work with numbers: add, multiply, mod, increment, decrement. There's also another category of operators called the assignment operators. And there's a ton of these, but really nothing to be scared of. We start off with our good old friend, just the equal sign. So we've done this a lot. When we create variables, we assign values. So we use the equal sign to assign values, x equals 5, right? But we also have like a hybrid operator where we take one of our arithmetic operators, plus, minus, multiply, whatever, and we combine it with an equal sign. And so here, Lucas, is where you can increment or decrement by more than 1. So the plus equals operator, which looks something like x plus equals 3, is the same as adding and then storing back in. Right? So you can, this is just a combination of addition and assignment. Jesse in chat says, is there any advantage to using minus minus rather than -1? Not really. You can use either one in your program. I guess very slightly. I feel like hitting the minus key twice is a little bit faster, but to be honest, there is no real advantage, I don't believe. So if you prefer to use like minus equals 1 or adding -1 and then storing it, something like that, they all pretty much do the same thing. Lucas, I see you have your hand raised. Is that another question?
Oh, sorry,
Or-
lower it.
Okay, no problem. Yeah, so plus equals, minus equals, you can do times equals, divide equals, mod equals. The rest of these are not important. We will not cover these, but these, there's a lot of them, but they're really not too scary. It's just a combination of an arithmetic operation plus an assignment. So it's a shortcut. Really, if you didn't want to use any of these, perfectly fine. You can just do what's on this right column, right? So there's an example, and then here's it says, okay, this plus equals 3 is just the same thing as x equals x plus 3. Or x times equals 3 is really just the same thing as x equals x times 3. And we have our comparison operators. So some of this we just saw, greater than, less than. If you want to do greater than, equal to, less than or equal to, they're here as well. So on our keyboard, we don't have a greater than equal key or a less than or equal key. So we just use a combination of symbols. We just put the equal sign afterwards. And it does what you would expect it to do. The thing that's a little bit special and you'll need to pay attention to, and you probably will mix it up a few times. I know I do. I still do to this day, is comparison. If you want to check if two things are equal to each other, you can't use a single equal sign. Can anyone tell me why? Why can't you use a single equal sign to compare two values in Java? The answer is just, we're already using the equal sign to do something else. We're using the equal sign to do assignment. So it already means something in Java. So we can't have it mean something else. So we need a new symbol, a new operator for equality. And very creatively, it's just two equal signs. So remember, a single equal sign means assignment. Two equal signs means equality or checking equality. So you can do like x equals y, and that will check if x and y have the same value or not. Just like we have an equality check, we have an inequality check. So are things not equal to each other? And here, the exclamation mark means the not. And then we have an equal sign. So exclamation mark equals means not equals. And it does what you'd expect. It checks if things are not equal to each other. So for example, if I have my two ints, x equals 8, y equals 8, right? So I can print out y or x greater than or equal to y. And so this will now be true because they are equal, right? So it prints out true. We can do x equals y, and that is true. And we can do x not equals y. This will be false. If for some reason you forget the double equal sign and use a single one instead, confusingly, Java will not complain, or Eclipse will not complain. If you run it, it's 8, which is a little bit weird. So what's actually happening here is, since we don't have two equal signs, we're actually doing assignment here. So we're actually assigning the value of y to x. And just as a the value, if you try to give this a value, it just gives whatever y is. So if I change y to, I don't know, 10, now the print statement will say 10. Right? So it's kind of a bug because maybe you were trying to do equality checking, wanted this, but if you have a single equal sign, it's not like missing a semicolon. It will not complain. It will try to proceed, and it might do things that you don't want it to do. And so that's a common bug. We'll probably see it in this class. Just keep an eye out for it. Finally, I know we're tired of operators, but the last category is these three right here, which are our logical operators. And these deal with the Booleans, our true false values. So we have and, or, and not. I'll begin with not because it's the simplest one. Not just flips the Boolean value. So here, if you have a Boolean that's true, not true is false. Similarly, not false is true. So what I mean by that is like this. So if I have a Boolean B and I say it's true, and then I can create another Boolean, I don't know, A, and I say it's not B. So not is the exclamation mark. It's just like the not equals is not equal sign, exclamation mark equal sign. So I can do not B, and if I print out A, this is going to give me false, because it flips it. True becomes false, false becomes true. If I have false at the beginning, then not false is going to be true. So not flips it. And or are binary operators. So that means they take two values. They take two Booleans to be specific, and they have some sort of output, and takes the two values and checks if both of them are true, and is only true if both values are true. Any other case, it will be false. So and is pretty strict. Both sides need to be true. On the other hand, or is lenient. Or only requires that one of the sides to be true, either the left side or the right side, or both, it doesn't care. As long as one of the sides is true, then it will evaluate to true. So for example, now I need two Booleans. So let's say X and Y. One is true, one is false, one is true. And then Boolean Z, X and Y. So really quickly, I don't know, Kaden, will this be true or will this be false if I print out Z?
It will be false.
Yep. And that's because and is strict and requires that both sides to be true, but only one of them is. Only Y is true. So because only one side is true, the whole thing evaluates to false and we get false. If we change it to or, then we get true because or is more lenient. It only cares about one side. X might be false, but it doesn't care. If Y is true, then it's happy, and it is. So Z is true, and we get true right here. Just really quickly, these symbols, in case you've never typed them before, the and symbol is shift number 7. And the or symbol is on my keyboard above the enter key, and you have to press shift as well. So it's if you don't press shift, it's the backslash. If you press shift, it becomes the vertical line, the pipe, and that if you put two of them, that's the or operator. Okay. So that's operators. Again, running through them really quickly. We have our arithmetic operators working with numbers. We have our assignment operators, which give values to variables. And a lot of them are just combinations of an arithmetic operator plus a simple assignment. We have our comparison operators, which are asking a question. Is X greater than Y? Is X equal to Y? Things like that. And it gives a Boolean result. And working with Booleans, we can use logical operators. Or and take two of them and produce some sort of output depending on what those two values are. Not takes one value and just flips it. Any questions about operators in Java? Do not see anything. So with that, I'll go to the slides. A lot of these slides already talked about. So really quickly, we have the characters, the last data type on that chart. Characters are just represent a single character on your keyboard. Right? So it's different than strings, which you might have heard of. Strings are whole words. Characters is just a single one of them, a single character. And we represent it with our single quotes, not double, single quotes. And really creating them is very simple. So char is short for character. So char C equals single quotes, and then maybe it's an R, right? And we can print out the character. And oops, there's a problem. The problem is I missed my semicolon. So if I run it, it's an R, right? Not too interesting. But there are actually a couple interesting things about characters. There are some characters that are hard to type, that don't exist on our keyboard, right? One of them is the tab character. So tab is on our keyboard, but it's kind of weird to have a tab like that. And also it's hard to see, but it does print it out. But you can also represent tabs another way. So there's a backslash. Backslash in Java represents escape character. And so when you see it, or when Java sees a backslash, it says, okay, what follows this character is something special. It has a special value. And so if you have a T after the backslash, it says, okay, I know this just means a tab character. And so it takes the backslash T and replaces it with a tab, essentially. And so I don't want you to be confused, because I said a character is a single character, but I have two things inside the quotes. Well, what's up with that? It's because this backslash is like saying, it pairs with something else. And it says, hey, whatever is after me has a special value, and it's like a special character. It's not just a letter like R is. Right? There are other ones. Kind of unique is if you actually want a backslash character, then you need to do two backslashes. Because if you have a single one, then Java gets confused. Backslash means whatever's after has a special value, but there's a quote afterwards, doesn't make sense. So you need two backslashes. So two backslashes becomes a single one. And that's just because a backslash has a special meaning. So you need to do two of them to say, hey, I actually just want a backslash. I don't want a tab or any other special character. I just want a backslash. But here's where we finally get into the question I had at the beginning of class, how to convert doubles to ints. And you might think, what does that have to do with characters? But we'll see very shortly. But to answer that original question, how to convert doubles to ints, there's something called typecasting. And I actually saw in the homework, some of you used it, which is great. Maybe you knew what you were doing. Maybe it was just a suggestion by Eclipse, because let's go back to something like this. So int x equals, I don't know, 0.5. Obviously, we know that this does not work. 0.5 is a double. Doubles are a larger data type. We can't convert it to an int without losing information. However, we can kind of force it to convert. And if we hover over it, it says type mismatch, cannot convert double to an int. But there's also two quick fixes available. The first one is, or the second one is what we did before. We just changed x, instead of x being an int, we just say x is the double. But the first one is adding a cast to int. And if we click that, what it does is it puts this. And this is called a typecast. And what it's doing here is just saying, hey, whatever is after me, I want to, it's actually an int, right? And so this is you explicitly saying, hey, take this 0.5 and convert it to an int, right? And Java's like, okay, I can figure out how to do that, because while I can't do it like kind of automatically, because I would lose information, I can still do it if you really force me to, because they're not too different from each other. They're both numbers. So even though one has a decimal value, and ints don't have decimal values, they're close enough that I can kind of force it to convert. And so what it does is it just truncates. So here x would be 0. Right? But if I do something like 7.3, then x is 7. So if you try to convert ints to strings, that would not work. So typecasting has limitations. It's mostly only used with these primitive types. So like if you want to turn an int to a short, for example, if you remember, a short is just a small data type that holds whole numbers like ints. You can do that conversion with a typecast. Usually, or sometimes these typecasts might lose information. Here we're losing the decimal value, right? But we do successfully convert the types. And so what it looks like again is the type you want to turn it into with parentheses around it. And to be safe, I sometimes like to put parentheses around the value. It's not necessary, but I want to be sure I convert this full 7.3. So some things is harder to convert, but what I'm about to show is actually some interesting conversions that you can do. So you might know that Booleans, true, false, are often represented as zeros and ones. And so you might be able to guess you can convert Booleans to ints. And so you can actually do that like this, or actually, take that away. I mixed up my Java and Python. You cannot convert Booleans to ints. But what you can do is convert characters and ints to each other. And the way that works is through something called Unicode encoding, or you might be familiar with ASCII. ASCII is a small subset of that encoding. If I bring up a table, this is called a Unicode table, or you might find it if you search like ASCII table. So just to show you guys, like I search up ASCII table, and I can paste this into chat. We got the same picture on the slides. So what it says is, this is our decimal value. Here's our character. So for example, the character capital P is the same thing as the decimal number 80. And so what I can do is, well, I can take a character, capital P, and cast it to an int. And so this will take my character and convert it to an int. If I hit run, x becomes 80, as we would expect, right, from this table. P right here is 80. We can also do it the other way around. So we can, great, so char x is, we want to take an int and cast it to a char, right? So we put char in parentheses, and maybe this time I want a u, that's 85. So I take the number 85, cast it to a char, and it's u, right? So ints and characters actually can be converted between each other. It's not always the most useful, but it can be sometimes. And maybe one thing where it is pretty useful is for special characters. So for example, all of these, right? So say I wanted, I don't know, this square. Yeah, so this square seems like 254, so we can try that. I want this character 254. If I hit run. All right, so that table is a little bit weird, but you can see I got this weird symbol. I don't know why that is the case. Let's see if it's on this table. Not sure. But you can also look up Unicode characters, things like that. Table. But the idea is some characters are hard to represent on a keyboard. We don't have keys for them, but you can still make a character variable for it. There's also another way you can do it. So if I go on here and I find like a symbol, like the pound symbol, it's Unicode number U plus 0083. And this is not something that you need to remember if you don't want, but I want to show you that you can actually put this into Java. And so what you can do is \u, and if you remember, the backslash is like a special value. So \u means I want to put a Unicode character in here, and it's the Unicode character 0083. The red underline goes away, and hopefully if I run this, yep, we get the pound symbol, right? So if you want to create a character for a symbol that you don't have a key for, so this is the one that we had before, or it looked like this, the weird symbol that we had. Again, like this weird 1/2 fraction symbol. I don't have a key for it. I can't type it on my keyboard. But what I can do is look at the Unicode, it's 00BD, and I can change that to 00BD, and it run, and it gives me the 1/2. You can even do like emojis. Let's see. If I try emoji, like just the smile, it's 1F60A. Don't know if this will work, but we can try it. Yeah. Yeah, so the range of these values can be a little bit too big. So it only supports Unicode characters that are 4 digits. So here, this one is 5 digits. You can still do it, you just have to do something different. But the other ones, you can see like the 00BD, the 4 character combinations do work. So like this one will work. Right. Missing the closing. Here's the 0 with a slash to it. All right, so that's pretty much the material for today's class. Going over the data types, finishing up that table, going over Booleans and characters, as well as operators, and also converting between data types. What's linked to Unicode? Here's just the first one that came up on Google, but you can find other ones if you just Google Unicode or ASCII. But yeah, put in chat. Any questions before I go over the homework and end class today? Over anything we just covered? All right, so the slides, there isn't too much exciting things that we can do for homework just yet. But this week, I think just a little bit more practice creating variables for different types. So the first one of these shouldn't be too hard. I just want you to create some of these variables, maybe print them out. So an integer with the value 5, a double with the value 1/2, or I should really just say 0.5, and also a float with the value 0.5. And this one might be a little bit tricky. You have to remember something that we did last week. If you have trouble, just reach out to me. Creating a character. And if you want a challenge, don't just type the letter T. Do that converting thing that we were doing. Take maybe a number, an integer, and convert it to a character. So look up what lowercase t is. And also a Boolean with the value true. Right. So create a variable with all these primitive data types. That's part 1, print them out. And part 2 is just practicing Boolean expressions. So I have this kind of crazy looking thing here. So here's an expression, and I want just values for A, B, and C that make this expression true. So I will post this, include this line in the Google Classroom post. You can just copy that into your own code. It's just setting this variable. You might want to say like Boolean, but it's just setting this equal to some expression. And I want you to find values for A, B, C such that this variable is true. And so you can do this just by brute forcing values if you want, or you can look at this equation and say, okay, if A is true, B is false, and C is false, what is this? What is that? How do they all combine together? Does it work? Does it not work? So yeah, it shouldn't be too hard. Worst case, you can just brute force. You can just try a bunch of different values and see what the output is. Yeah, so that's the homework for this week. It will be posted to Google Classroom. Try to get it done by before class next week. And that's all I have. So if there are no questions, thank you for sticking with me. Feel free to sign off for today, and I'll see you next week.